50,000 years ago, humanity was not one species staring heroically into the sunset. It was a crowded family gathering spread across 3 continents, and the seating plan was complicated. Neanderthals occupied much of Europe and Western Asia. Denisovan-related populations lived across parts of Asia, although fossils have revealed only fragments of their enormous story. On Flores, a small-bodied human called Homo floresiensis survived astonishingly late. On Luzon, teeth and bones preserve another peculiar form, named Homo luzonensis. Other lineages had also persisted far longer than their anatomy once led researchers to expect. Today, only Homo sapiens remains as a distinct living human population. So, what happened to everyone else? The obvious answer arrives wearing dramatic music. Modern humans swept out of Africa, defeated every rival, and claimed the planet. Very tidy. Also, the evidence refuses to stay that tidy. There is no archaeological record of a single worldwide war, no fossilized campaign map, and no securely identified last individual making a final stand on a cliff. What exists instead is a patchwork of encounters, contractions, disappearances, and genetic exchanges unfolding over thousands of years. Prehistory, inconsiderately, did not organize itself into a season finale. Even the cast list needs care. Fossil species are labels built from anatomy, age, geography, and when preservation allows, genes. Neanderthals and modern humans were visibly and genetically distinct lineages, yet they had children together. Denisovans are known mainly through DNA, a few bones and teeth, and a jaw identified through ancient proteins. Homo luzonensis rests on a small collection of teeth and limb bones. These may be called species, populations, or lineages depending on the question and the taxonomic rules being used. The branches were real. The borders between them were not necessarily brick walls. Neanderthals provide the clearest test. Improved dating indicates that their characteristic archaeological record ended at different times in different European regions, broadly around 40,000 years ago. Modern humans overlapped with them for perhaps several thousand years in parts of Europe. That is enough time for contact, competition, imitation, avoidance, and interbreeding, but not enough evidence to assign one identical outcome everywhere. Did sapiens simply kill everybody else? Genomes reveal something more complicated. Most living people with ancestry outside Africa carry a small percentage of Neanderthal-derived DNA. Ancient genomes place a major shared period of admixture about 45 to 49,000 years ago, while other analyses indicate earlier and repeated gene flow in both directions. So the first reversal is this: Neanderthals did not simply vanish when modern humans arrived. Some became ancestors of later humans. That does not mean interbreeding explains everything. Genetic inheritance can survive even when a population's identity, networks, and characteristic anatomy disappear. A cup of dye can remain visible after being poured into a lake. The cup has still ceased to be a separate container. Demography is less cinematic than a duel, but it can be just as final. Why would small populations be so vulnerable? Neanderthal populations appear to have been relatively small and fragmented. The genome of one Altai Neanderthal records extremely close parental relatedness, although one individual cannot represent an entire continent. Other genetic evidence also points to low diversity and limited effective population sizes in at least some groups. Small populations live close to the edge. A few failed hunting seasons, an epidemic, the loss of several adults, or a broken connection with neighboring groups can matter enormously. A modern city can lose a busload of people and continue functioning. For a band numbering in the dozens, there is no replacement bus, and possibly no neighboring route. Expanding sapiens populations may have held a demographic advantage, more people moving through wider social networks, carrying materials, information, and potential partners between groups. No superpowers required. If one population repeatedly receives newcomers while another remains thinly scattered, the arithmetic gradually changes the landscape. Competition for territory and resources may have contributed, but direct battle is not required for one population to outnumber, absorb, or replace another. Did climate do it instead? Abrupt cold and dry episodes coincided with regional Neanderthal depopulation in parts of Europe. Habitats shifted, familiar prey moved or declined. Groups already divided into small pockets could lose contact. On islands, environmental disruption could be even more unforgiving. Climate looks like the obvious culprit until that explanation fails too. Neanderthals had survived repeated glacial swings before. Climate affected modern humans as well, and different lineages disappeared in different places and at different times. Climate was pressure, not a universal delete button. Evolution apparently neglected to install one of those. Island Southeast Asia makes the chronology stranger. At Liangbua on Flores, Homo floresiensis bones date to roughly 100,000 to 60,000 years ago, while stone artifacts continue to about 50,000 years ago. Those dates are the youngest known evidence, not a death certificate for the lineage. Modern human arrival in the wider region may have overlapped closely, but direct contact at Liangbua has not been demonstrated. At Callao Cave in the Philippines, Homo luzonensis is represented by remains around 67,000 to 50,000 years old. Its ultimate fate is unknown. No genome reveals whether it contributed ancestry to later people, and a few teeth cannot narrate an extinction. They can only prove that another kind of human had reached an island that was never connected to the mainland by dry land. Evidently, complicated travel arrangements are not a recent invention. Other discoveries warn against assuming that archaic looking lineages disappeared early. Homo erectus survived on Java until at least about 117,000 to 108,000 years ago. In South Africa, Homo naledi, with its surprising mosaic of traits, dates to roughly 335,000 to 236,000 years ago. Primitive looking does not mean first to leave the stage. What does extinct mean if groups interbred? Denisovans make disappearance even harder to define. Their known fossils are sparse, but genetic evidence places Denisovan-related populations across a vast part of Asia. A mandible from the Tibetan Plateau shows their presence there at least 160,000 years ago. Living populations in Oceania and parts of Asia retain Denisovan ancestry, sometimes in substantial proportions. That survival is not merely decorative. Some inherited archaic variants influenced immunity, metabolism, skin biology, and adaptation to high altitude. Natural selection kept useful pieces while discarding many others. A genomic lost and found with extremely strict management. There was probably no single reasons, only Homo sapiens remained visibly distinct. Different populations face different mixtures of climate stress, habitat change, small numbers, isolation, competition, chance, and absorption. Some may have died out locally. Some retreated until no viable network remained. Some were incorporated into larger sapiens populations. The balance among those processes is still debated, and it need not have been the same twice. Are humans truly alone? Only one human lineage now builds cities, names fossils, and argues over the definition of species. Ecologically and taxonomically, humans today stand alone. But genetically, only us is not absolute. Neanderthal sequences travel in billions of living bodies. Denisovan inheritance persists from Asia to Oceania. Other archaic contributions may still be hidden in genomes whose source populations have no name. The other humans are gone as separate peoples. Some of them never entirely left.
Thanks for watching this video. Don't forget to subscribe